So now let me introduce you to our esteemed speaker. So Ravi sir has been a well-wisher of this center for quite some time. So he is literally a rock star, not just in AI terms, but that he has a rock band. He's an amateur guitarist along with his best friend for so many years. They play regularly. I don't know, should I say over to mundane things, that he's a CEO and co-founder of Symphony Tech as well. He did his MTech in data analytics at the age of 61, thereby proving that age is just a number. But as if that was not enough, after that he went cycling in the Himalayas. Okay, so just to throw the point further, right? But today he's going to demystify this topic in front of us, and hopefully at the end we'll have a better understanding of what an AI is, what an algorithm is, and so forth. So Ravi sir, over to you.
Move around, or I will study. Okay. Yeah. Okay, I trust you can hear me. Good afternoon, everyone. Thank you for the Venture Center team for putting us all together here and giving us an opportunity to interact. So, here we are discussing AI, demystifying AI. There is one promise that I come with. I'm not going to use any math. I'm not going to bombard you with Greek symbols, with mathematical equations. Neither I'm going to talk any jargon that is connected with AI. Because the moment you talk to anybody about AI, they come in a barrage of terms that are unfriendly and that are very difficult to understand. So let's not do that. The topic is demystifying AI, and I'm going to talk plain and simple language and try to understand what is AI. So as I was introduced, that I did my master's in this very field at an old age, as they say, at the age of 60. But then probably I'm the youngest graduate in this room, most recent graduate. So you can hear from me and you can understand the latest things. So let me start with stuck here. So the moment I graduated, and like everyone does, I went to my grandma. Yeah, we call our grandma Aji in Marathi. So I said, Aji, grandma, today I got a degree in AI. Yeah, that's the first place you run to when you achieve something. The grandma was, oh, congratulations, but what is AI? Actually, she didn't know what was AI. She had never heard of AI because she is not exposed to this big bad word which keeps on talking about jargon and the Greek language. Right? So she said, but what is AI? I said, AI is artificial intelligence. Krutim Buddhivatta. Yeah, I told her in Marathi. What was the response? It was startling. He said, hey, Bhagwan, what happened to your natural intelligence? Yeah, this was the response, which is true. If we have natural intelligence, why should we have artificial intelligence? Why has this term got coined in the recent years? And what is it going to do for us? These are the questions that we are going to explore today and we are going to talk about. So let's see. The questions I'm going to bring up on the screen, and these are the questions we are going to answer in the next 20 minutes that I'm going to speak. And after that, the session will be open for questions, answers, and discussions. Yeah, feel free to ask any questions. Even while the session is on, feel free to interrupt me, raise your hand, ask me questions. I'm ready to go along with you. So, what is artificial intelligence? What is machine learning? Why? Who is becoming intelligent artificially? Who is learning? And if somebody is learning, who is teaching? These are the questions that we need to understand. Right? So the first answer is to make computers think like humans and to make them reason like humans. It's not just thinking, it is reasoning. What is reasoning? You look at a situation, you evaluate the situation, you try to weigh the pros and cons of responding in a certain way, you reason, and then you respond. So the computer is now capable of not just thinking, but reasoning like humans. And that is artificial intelligence. What is machine learning? I can say upfront that machine learning is supposed to be a subset of artificial intelligence. So machine learning is a part of AI. Yeah. So machine learning is to make computers work without having to program. We have seen in the past 4 decades probably that the IT revolution has come to our country, and there's a battery of programmers who sit down and write those cryptic languages and those programs are fed to the computers, and computers know how to work, and they give you all kinds of things. They play videos for you, they probably bring out word processors, they bring out spreadsheets. Yeah, these are written in some code. Now, no longer is somebody going to code. The machines are supposed to observe, they are supposed to figure out what is to be done and work on their own. So the ability of a machine to perform, the ability of a computer to work without having to program it is machine learning. So who's learning? Who's becoming intelligent? The machine. Which machine? The computer. Right? Who's learning? The computer is learning. And who's teaching? We are teaching. So if there is any element of AI or ML that is coming in, the person who's bringing it about is you and me. Yeah. So now the biggest question after hearing all this, why? Why do we want to make computers tick like you? Why do we want to make them intelligent? Why do we want the machine to learn? And why are you teaching the machine? What was wrong with the dumb computers? Garbage in, garbage out. That term has been flying around for quite some time, right? Since I was in school. So this why is the question we are going to ponder over. Why are we making computers intelligent? Why are we teaching them to learn? Won't they take away our jobs? That is the biggest fear in my mind. That okay, tomorrow if the machine starts roaming about and learning on its own, I'm going to become brilliant. Yeah, is that the truth? Should we be aware of that? Is something that we explore. Yeah, and after that you can ask me questions. We'll have a detailed discussion. So, looking at this, going into brass tacks, really, computers are capable of doing only 4 things. There is no 5th thing that a computer can do. So let's try and understand what are these 4 things. Number 1, computers have a huge memory which we humans don't. Yeah, it is now gigabytes and terabytes of memory which you can recall. Yeah, we may also have that memory, but you can't recall. So the differentiator that the computer brings to you brings to your advantage is that it has a huge memory. Second, the computer works with a super high speed, rocket speed. We can't work with that speed. If I ask you, I don't even remember my tables which I learned in school. Yes, so computer is able to work with a super high speed, which we humans are not. And remember, I'm going to talk only about 4 things, not even the 5th thing. Third, computer does calculations as well as does all the work with a high degree of accuracy, which we humans don't. We make mistakes. Yeah, at times. Even while speaking, I may be using all grammar, but the computer won't. So high degree of accuracy. And the most important thing, and the 4th thing that I want to bring up, is that computers don't get tired. There is fatigue. Yes, there is load, and that load slows down the computer. But metaphorically, the computer doesn't get tired. Now, what we need to do is, we humans need to use these 4 attributes of computers in order to harness them and make them work to our benefit. There are certain good things about computers as well. Yeah, and that is, we humans also do this, but the computers do it in a super way. Like humans, the computers can talk to each other. You have seen wide area networks where a computer sitting here in Pune is able to talk to another computer in San Francisco. It's not just chatting that you see, on WhatsApp and on Google Chat. Yeah, it is also, if you're giving a task to the computer is able to communicate to some other computer around the world, split the task, give it to the other computer, both of them will work simultaneously, put the results together and give them. Yeah, this is, in technical terms, it is called distributed processing. This is what computers are able to do. They are able to share their memory. Yeah, there are now, we have heard about big data, which is a part of our learning. Now, big data, the data is huge. It cannot be fitted on one disk or in one memory. So what is done is the entire task is taken, sliced and chopped into pieces, distributed across various computers, and it is resident in their memory. They are technically called sharding. Yeah, so shards, number of pieces are made and they are distributed on computers so they can share memory. They can share tasks. That means if a very complex task like weather prediction is given to them, a single computer can slice the task give small tasks to multiple computers around the world. Each computer will do the task that it is assigned to, and then they will all put the results together and present the results to you. So these computers are very collaborative creatures. They are working in collaboration with each other. And this collaboration is making it possible for computers to behave like humans and to work like humans. Yeah, they can share space, which is either memory space or disk space. So this is how I need to look at computers, and this is the reason why I need to use computers. This is the reason why I'm teaching computers to think like. So this is kind of a synopsis to what we are talking about. Now, what we need to do is we take advantage of these capabilities and we make computers intelligent. So I've just established why I'm doing all this. We make computers do the work that we cannot do or we don't want to do. There are many types of work which I don't want to do. I don't like to go to office. Who likes to go to office? I like to sit at home and enjoy life. Yeah. So there are some mundane works that somebody in the office tells me, look at this spreadsheet and transfer all this data from one file to another file. I don't want to do such jobs. Yeah, so these jobs, which are some things which we don't want to do or which are very hazardous to do, like I want to keep an eye on the nuclear power plant. I don't want to be responsible for such a thing. Yeah, I want to keep an eye on a missile and make sure that it is not fired by somebody accidentally. Such jobs I don't like all that. Yeah, and hence these are the jobs which we either can't do because of our limitations or we don't want to do. And these are the definitions of AI and ML. AI, once again, is to make computers think like humans and reason like humans. And ML is to make computers work without having to program them. So these are our simple definitions. Yeah, I promised you at the beginning of the session that I'm not going to use any jargon. I'm going to break it down to as simple terms as possible. So let's talk about AI first. In AI, one of the techniques that is very commonly used is called reinforcement learning. Don't worry about reinforcement learning. It is just a jargon for all of us. Yeah, so when computers are going to learn, reinforcement learning is a mathematically oriented technique that is used to teach computers how to think like humans. So let's take an analogy. This analogy is given very often in academics as to how computers learn. So let's think about how humans learn, or better, let's think about how animals learn. Yeah. So there is this alley cat which is there in my gully, and the cat has a dilemma. The cat would really love to know about all around the town. Yeah. Or if they can sit in front of the shop where they sell fish in the market. So the cat tries out everything. So everything is done by trial and error. So the cat one day goes for a walk, owns a walk. On another day, it sits in front of the fishmonger shop. The results are, if you sit in front of the fishmonger shop, you get a morsel of fish. If you go for a walk, nothing, you're left hungry. This is something that the cat has learned to try. Right? So the cat registers this. Sitting is better than walking up. Will the cat do this in a single instance? No, it can be an accident. So the cat forms habits. It goes, number of times goes for a walk, and it always realizes that very infrequently, very rarely doesn't get anything to eat. But when the cat sits in front of the shop, the cat gets a fish more often. Yeah, this is reinforcement learning. Now let's look at the technical tools that go with reinforcement learning. In the technical jargon, the cat is called an agent. Yeah, so there are these small agents which are artificial programs, small pieces of programs which are emulated, which is emulating in the car or this chair, or it is emulating the staircase, it is emulating an elevator. So each one of them is modeled by a small program running on a computer. The walking or sitting is called the action on the state. That means various things that the cat tries out. Yeah, so the elevator you can try taking it at high speed, you can take it at low speed, it can stop with a jump, it can stop slowly, and see what the response of the human says. So the elevator is quite well. How to start, right? The fish and the hunger is the reward and penalty. Yeah, we call it probability penalty, but in technical terms it is called the negative. And these are numerical. So there are mathematical methods by which every agent is put through various situations, various complex situations, and a reward penalty is given by the system. And this whole thing is called the environment. And after that, when the machine learns, whatever is the learning is called the policy. Yeah, so this is how computers learn. They try out various things. Now the cat and walking is a very simple example of agent-based modeling. But in real life, there will be thousands and billions of agents which are working in an environment, interacting with each other. The environment is changing dynamically, and hence all the interaction between environments and everything that is happening now is very complex for any rule-based programming to be done. If I ask you to write a program for aircraft landing system, automated landing system, it's going to be Herculean task. So what is done is small computer programs are written which emulate aircraft. Yeah, these are called the twins. These programs are called the agents, and these agents simulate the process. So let me show you certain examples of how complex things can get. Right? So this we used to do pretty often even before the age of AI. It was static simulation. That means we used to create small programs. That blue car that you can see that it's an agent. This road traffic signal is an agent. The people waiting here to cross are agents. Yeah, and they are given commands to work like real humans, real cars. Yeah, the road is an agent. The design of the road is a property of an agent. Yeah, so agent-based modeling, or in this specific case, it is called technically discrete event simulation. So such simulation used to be done even before the AI practice came into being. Now what we do is we ask each autonomous agent, this word is very important, each autonomous agent, namely the car, the signal, the human, to behave in different autonomous ways. That is, I'm not going to when you try everything actually. And this is done very, very fast. So all kinds of things are right. The human knows that if a car is coming at a certain speed and you go there, you are going to get under the car. Yeah, so this is the reinforcement learning that happens. And at the end of it, after thousands and thousands of trials, I'm not saying millions because trials are in thousands or tens of thousands, each autonomous agent understands the behavior that is expected in order to have a safe, smoothly flowing trial. Yeah, so this is an application of AI. Let's go to something more complex. What is the wrong word? Chatbots. Yeah, they're called large language models. Yeah, so chatbots, you go to ChatGPT and ask questions that are kind of out of the routine. It will give you real answers. Right? So chatbots, generic chatbots like ChatGPT are okay for generic questions. But if you ask questions which are specific, then the chatbot is likely to hallucinate. Yeah, this is a technical word that is used, which is very close to what we humans do. Yeah, hallucinate. So chatbots can hallucinate and they can give completely off the track answers. So we need to train the chatbots to the specific area. I'm working right now at a project where I'm training a chatbot on phonebus, on injection modeling, right? And this chatbot is being refined. So you first give it a body of knowledge. It reads through PDF files and a lot of material that is there. It looks at videos, yeah, and it forms its own hypothesis. Then the human asks it questions. The answer that they come can be good or it can be unexpectedly different. The human is supposed to fine tune the chatbot. Say, yeah, this is not a correct answer. We should put it this way. We should put it another way. Right? This is called human feedback reinforcement learning. Yeah, RNHL. Reinforcement learning based on human feedback. So humans keep on feeding back to the chatbot, and slowly the chatbots become intelligent in the specific area of technology or of any art that you are teaching. Yeah, so this is a big one that is going on right now, where technical experts are transferring their knowledge to such bots, to such large language models, who can assist other people and spread knowledge. So this is another. I talked about this automatic landing system. There are many components of this. There is a draft, there is a temperature, there is some kind of air current that is going around the clouds, there is a visibility. Yeah, all the control system of the aircraft, there is the gyroscope, there is the angle of incidence, angle of landing, right? And what kind of vibrations are there. Now the aircraft control system needs to learn how to land an aircraft safely in spite of all this. If I teach it only one situation, it is going to fail. Yeah. So an agent which simulates each and every one of these, the landing gears, the angle, you can see when you're landing, if you look out of the window, the flaps are going up and down. Yeah, this is the automatic control. So the flaps, the control system, or the solenoids for the flaps, these are individual autonomous agents which are continuously communicating with each other, which are getting impetus from the environment. Right? Now, being in the area of pharma and biologics, you can think about the same thing in a bioreactor. Yeah, the bioreactor is growing cells, and then it is taking impetus from what is the kind of feed, how much is the sparging, what is the kind of oxygen that you are feeding, what is the time, what is the temperature. Yeah, these are situations where all the factors are interacting with each other also. So, by slowly going through learning in a simulated manner, reinforcement learning will take place and agents will learn. Yeah, so this agent-based modeling and reinforcement learning is a major method in which AI is at the bike. I think this is the Google self-driving car. And a self-driving car is also taught to look at various situations. Again, that is a reinforcement learning. Yeah, so this is how things work, and at the base of it, there is a lot of mathematics. So if you ask me, I'll tell you towards the end of the session as to what mathematics lies under this, and it can be pretty daunting and pretty deep. But I will promise you not at all. Yes.
How many times would that reinforcement be required for it to form a policy?
The policy, again, it's a statistical thing. That you form a policy if you are exposed to statistical analytics, there is always something called as confidence. So there can never be 100% confidence. The amount of confidence will go on rising as you go on increasing the reinforcement trust. It can never become 100% because statistically or technically, 100% knowledge can never be acquired by it. And there is always some.
What is the benchmark? How many times will it be?
Typically, it depends upon the application. Something like that. Yeah, it may take millions of runs, but it can be done really very, very fast. Yeah, to look at the comprehensive thing of the situation. Whereas something like this, I can train this within a month to give a reasonably good thing. And in a month, maybe there can be rounds, maybe 3,000, 4,000 rounds of human feedback. These are the kind of things. It depends on the criticality of the application and the amount of confidence you want to have in it. Okay, now let's go to machine learning. Yeah, what are the machine learning areas that maybe I have encountered and maybe perhaps some of them I'm working on? So in machine learning, remember, why is machine learning important? Because earlier, when I used to practice statistics, I used to talk about small sample statistics. You all know, you have been in scientific areas, you know the t-tests and f-tests and ANOVA that we do. These are all small sample tests. But now data is becoming big. Data is becoming huge in volumes. And if we need to deal with such big data, much bigger than before, we will need to look at machine learning. Yeah. The second reason is data is coming very fast. Yeah, when the autonomous car is moving, it can see an obstacle in between. It needs to take action immediately, right? When there is a certain there is an aircraft that is landing, it needs to in real time look at the situation and fine tune its landing gear. Yeah, so the data is coming very fast, and hence we need to use techniques like streaming process analysis. The process is not going to give you the data, you take it to your lab, do the analysis, say, use Minitab, give you results, and then test your hypothesis. No, the data is coming, I need to respond. And that is the reason why machines need to learn. I do not have the time to program the machines to every specific situation. Yeah, the machine needs to learn. The machine needs to also, it needs to learn and it needs to respond. So this needs to happen very fast, and that's the reason why machine learning is important. Data is coming in unstructured formats. Earlier, what we used to say, hey, give me data which is in these fields in the database. When I learned computer science, this term fields was very mysterious to me. What is a field? I knew only football field. So field is, then I realized field is a place in which you enter the data, but now everyone is probably using the term fields. So we had to put structured data in the fields, and if instead of my instead of my date of birth, if I put my school name, it is to say no, can't find work. Yeah. So data used to be very structured and you had to be very disciplined. Who's disciplined? I'm not disciplined. I'm going to give you the data, hey, take this data and do analysis. And the data is in form of pictures, audio, video, text, e-sensors. Sensors are giving signals, electronic signals, waveforms. So data is going to come in this form. And you need to do analysis for that. There is no choice. And hence, the data body is very large. We used to say, clean the data and give me, it must be in this structure format, only then I will do the analysis. No, the data is going to be hazy. When I take a picture of the city and I try to find out how many buildings are there, I am not going to ask first the haze to be removed. I will take the satellite picture, and if I want to check the land use, I cannot say remove the haze only, then I will do the other thing. Haze is never going to be removed. In spite of that, I need to do the analysis. So I need to do the analysis despite hazy, incomplete, inconsistent data without fixed formats. This is the reason why machine learning is better. And the value of decisions is very high. Decisions that are based on data are more likely to succeed. Decisions that are based on hunches are going to fail. So the value of data is being realized by humans, and that is the reason why machine learning becomes important. So what are these machine learning applications? Machines will observe, machines will learn, they will work. So what are these machine learning observation things that we are encountering? We all know Amazon recommendation systems and those bills that you get, but there are many more. Image analysis. That means the computer is going to look at images, maybe images of cells, the growth of tumor or the intensity of tumor. It is going to classify whether the tumor is malignant or it is not. Earlier humans had to make a judgment. Similarly, it's going to look at X-ray, it's going to look at the lung X-ray and say whether this person has pneumonia or not. So this is a fact you are seeing and you are making judgments. Biomarker analysis. When you develop drugs, you are making a judgment based on biomarkers. Now, based on these biomarkers, you need to do what is called as predictive analysis. So the computer, the machine has seen thousands of cases, and if it sees a particular progression or a particular combination of biomarkers, it knows where the disease is going. It knows whether your drug has efficacy or not. If it sees certain levels of certain markers go up and down, it knows whether it is inducing toxicity or not. So this is what image analysis and biomarker analysis is going to be. Another case, this we are seeing more often, I believe, improving sales, improving satisfaction. It's not just the sales. I can try and determine what is it that the customer likes. So these customer surveys, technically there is a term used for that. It is called propensity modeling. So propensity modeling is a major machine learning thing that people do. And every now and then, it will keep on surveying customers. It will keep on surveying what you like, what you don't like, and putting huge data together. The machine is able to make a decision about what my next like should be like. This cannot be programmed. It's too complex to program. The third one I've seen is text analytics. We have been saying that we have our Ved Upanishad scriptures which have got a lot of knowledge. What is that knowledge? No one knows. I don't know. So what can be done is it can be a combination of image capturing, OCR, optical character recognition in multiple languages, and trying to understand the sentiment and meaning behind what is written there. Then the essence of knowledge, not just what is written there. We used to do that, and we used to learn Sanskrit shloka. And we used to recite it, but we didn't know what they like. But then analysis using machine learning is able to derive the sentiment, the essence behind that, and if they try to make us better humans, trying to enrich our knowledge. So this is one of the major text analysis. Natural language processing is what it is called. So natural language processing has got a lot of elements. It has got word sense disambiguation. Word sense disambiguation is I'm sitting on the bank of the river is not saying that I deposit my money in the bank. So natural language processing has got decision rules of disambiguating the meaning of same word. It has got something which is called part of speech tagging, which means the sentence has got a structure, and that structure is elicited out of written text. And this is how your Siri and Alexa are going to work. So this is one of the major things. Recognition analysis is used very, very, very effectively. There are companies in India whose job is to look at every FIFA match and try to document who has passed the ball to who is at the center forward, what is strategy that was used, what is working, what is not working. Also, what is the performance and what is the better health? What is the diet that is given, how many hours of sleep? What is the nutrition? Yeah, and correlating it with the sports performance is something that machine learning has been good. These are all real, and this is what we have seen. Human gene therapy, now with natural language processing, large sequences of data can be analyzed, and you can make hypotheses and inferences out of that. So your gene sequences, the DNA sequences, can be analyzed, and you can correlate if there is a certain mutation in the sequence, what is that going to be? Right? So you look at the brain, you know how many sequences are there in the human body, some 3 trillions, and the natural language processing algorithms are able to analyze it. So in gene therapy, especially n is equal to 1 therapy, that means rare diseases, where there is only one person who has a disease, but you'll be able to find the antibody or whatever drug you want to have to treat that pattern. Yes, so this is becoming very effective. People are using it in gene therapy. Another direction, this is something which humans don't really want to do. So you have various scenarios that are taught to agents, and their hazards are prevented by putting preemptive actions in place. But all kinds of hazards with all factors interacting with each other. You know, what happens if there is a tsunami? What happens if there is high temperature? What happens if the acceleration in the of reaction goes suddenly high? It runs away. What to do? This is simulated by agents, autonomous agents, and you try to figure out what is the solution. How it works, I told you what it does, but how it works is there is a technology which is now coming in vogue. Now within the last 20 years it is coming in vogue, and that is the deep learning technology. I will talk a little bit about that. So in deep learning, we try to represent the human brain. You all are aware probably that human brain comprises of a lot of neurons, and these are all interconnected with each other using synapses. And then there is messaging that is passing up and down the neural system, and that's how you make decisions. Yeah, that's how you think, that's how you learn, that's how you memorize. So there is an equivalent that is created in a computer. It is called an artificial neural network. It comprises of multiple elements. These dots you see, they are called neurons. Yeah, the connections are between neurons. Yeah, these neurons are technically called perceptrons. Yeah, perceptron is a small computer program, and there is what is called as an activation function there. There it is an equation that transforms input to output. Right? And using this neural network, you are able to figure out underlying model of any natural or physical phenomena or biological phenomena that you see, any scientific phenomena that you see. And people are using neural networks for a variety of applications. Some of the major applications of neural networks are image processing, where you use a special variant of neural networks called convolutional neural networks. There are neural networks which take in information in series, in streaming process. They are called recurrent neural networks. And now neural networks are going beyond their intended use, and they are making the computer more accurate. I'm not getting into how they work, but they work exactly like human brain. So, yeah, artificial human brain is created in the computer. It is called the ANN or artificial human brain. So, AI and ML are very interesting technologies. There is a plus side of it. They can be productively used to improve quality of life, alleviate human suffering through curing of diseases and preventing them, improve resource efficiency and bring sustainable living. Sustainability is very, very important. We cannot plunder the natural resources that are given to us and bring about happiness in general. But there is also the flip side. If they are not used properly, if they are not used with a good intent, there is nothing proper or improper. There is always an evolution. But if they are not used with a good intent, if they are used with crooked intent, they can lead to wars, mass destruction, physical and mental maladies, disabilities, and depletion and dwindling of natural resources. So it is a double-edged sword that is placed in your hands. It is up to us humans now to train computers productively to achieve all this and not use them for this. Right? And finally, what is very important to know, and this is what I always say towards the end of any session that I conduct, that everything in life doesn't require AI. Or everything in life doesn't even require computers. Right? There is that real world which you can touch, smell, hear, and taste. And that world is very precious. That world is very important. One of the best things I like about Venture Center is when I walk in, is all the greenery, all the ambience, all the environment. And when I sit in the library and peacefully meditate, I can feel the touch of pages, some old pages in my hand, and that gives me a great amount of peace. Yeah, so this is important. I do not need AI or ML either to have chai samosa or to play tennis or to swim or go cycle. Yeah, and these are very important aspects in life, and we must savor them.